You take one sip. Within seconds, your body knows. Within minutes, alcohol reaches your brain. Within an hour, nearly every major organ has been affected. Your liver shifts into emergency mode. Your brain begins slowing its communication. Your heart beats differently. Your kidneys change how they handle water, and billions of cells start working to remove what your body recognizes as a toxin. Today, we're shrinking down, taking a journey inside the human body to watch exactly what happens after you drink alcohol, from that first sip to the final molecule leaving your bloodstream. We're going to follow its path, cell by cell, to understand the intricate biological response it triggers. The journey begins the moment alcohol touches your lips. But unlike a meal, which requires a long, complex process of digestion, alcohol is treated like a VIP with an all-access pass. It needs very little breakdown. A small amount, about 20%, is absorbed directly through the walls of your stomach. From there, it slips into the tiny blood vessels that line it. The remaining 80% moves on to the small intestine, where its absorption becomes even more rapid. The vast surface area of the intestine acts like a giant sponge, pulling the alcohol into your circulation with remarkable efficiency. The result is that within just 5 to 10 minutes, alcohol molecules are already traveling through your bloodstream. The peak concentration in your blood is usually reached within 30 to 60 minutes. Of course, this can vary. Having food in your stomach, especially fatty food, can slow this process down. Other factors like your body size, your genetics, and even how quickly you drink all play a role in how fast your blood alcohol level rises. But make no mistake, alcohol travels fast. Once in the bloodstream, alcohol is carried everywhere, but it has a special affinity for one of the most protected places in your body, the brain. It effortlessly crosses the blood-brain barrier, a highly selective membrane designed to keep toxins out. Once inside, it begins to alter the very fabric of communication between billions of your brain cells, your neurons. Alcohol is a depressant, hijacking your brain's natural signaling system. It enhances the effect of a neurotransmitter called GABA, which is the brain's primary off switch. GABA's job is to calm things down and reduce neuronal activity. Alcohol essentially presses down on this brake pedal, making it even more effective. At the same time, it suppresses the brain's main on switch, a neurotransmitter called glutamate. Glutamate excites neurons and keeps them firing. By blocking glutamate, alcohol is taking its foot off the gas pedal, so you have more brake and less gas. The result is a system-wide slowdown. You feel relaxed, your reaction time gets longer, your coordination suffers, your judgment becomes clouded as the prefrontal cortex, your brain's CEO, is one of the first areas affected. And as alcohol levels continue to rise, your brain's ability to form new memories is impaired, which is what can lead to a blackout. While your brain is slowing down, another organ is kicking into high gear. We now arrive at the liver, the body's master metabolic factory. This incredible organ performs hundreds of critical jobs every single day, from managing cholesterol to storing vitamins. But when alcohol arrives, an alarm bell sounds. Many of those routine jobs are immediately placed on hold. The liver recognizes alcohol, or ethanol, as a poison, and its detoxification becomes the absolute top priority. Over 90% of the alcohol you consume will be processed right here. The main tool the liver uses is an enzyme called alcohol dehydrogenase, or ADH. This enzyme gets to work converting the ethanol into a new compound called acetaldehyde. But here's the problem. Acetaldehyde is a highly reactive and toxic substance. It's actually estimated to be up to 30 times more toxic than alcohol itself. It can damage proteins and even DNA. Your body needs to get rid of it, and fast. So a second enzyme, aldehyde dehydrogenase, or ALDH, swoops in. Its job is to rapidly convert that toxic acetaldehyde into a harmless substance called acetate. This acetate is essentially vinegar, and your body can easily break it down further into carbon dioxide and water, or even use it for energy. This two-step process, alcohol to acetaldehyde to acetate, is your liver's critical defense against alcohol poisoning. But while the liver is heroically managing this detoxification process, there's an unintended consequence. Because it's so focused on breaking down alcohol, its ability to perform other key functions is compromised, specifically its ability to process fat. Normally, the liver is very efficient at burning fatty acids for energy, but with alcohol present, fat metabolism slows to a crawl. The chemical reactions involved in breaking down alcohol produce an excess of molecules that signal to the liver cells to stop burning fat and start making more of it. As a result, tiny droplets of fat begin to accumulate inside the liver cells. With a single episode of heavy drinking, this can happen. If it's an occasional event, the liver can usually recover, but with repeated heavy drinking, this fat buildup becomes chronic. This condition is known as alcoholic fatty liver disease. It's the first stage of alcohol-related liver damage. If the exposure continues, this can progress to inflammation, a condition called alcoholic hepatitis, and eventually to fibrosis, which is the formation of scar tissue. In some individuals, this can lead to cirrhosis, where the scarring is so severe and widespread that the liver can no longer function properly. Alcohol's journey doesn't stop at the liver. Its presence is felt system-wide. Take the heart. Alcohol can cause your heart to beat faster and, in some cases, irregularly. It also causes vasodilation, meaning the blood vessels near the surface of your skin widen. This is what creates that temporary feeling of warmth when you drink. But it's a deceptive feeling. Your body is actually losing heat more rapidly to the environment. Your kidneys also notice the change. Alcohol interferes with the brain's release of a crucial hormone called antidiuretic hormone, or ADH. This hormone's job is to tell the kidneys to conserve water. When alcohol suppresses ADH, the kidneys get the opposite signal. They stop conserving water and begin flushing it out. This is why you urinate more frequently when you drink. It's not just the volume of liquid you're consuming, it's a direct hormonal effect that leads your body to lose more water than it takes in, setting the stage for dehydration. And that dehydration is a key player in the miserable experience we call a hangover. But it's not the only culprit. A hangover isn't one thing. It's a perfect storm of several biological processes happening at once, usually as your blood alcohol level returns to zero. First, there's the dehydration we just talked about, which can cause headaches, thirst, and dizziness. Second, your sleep gets disrupted. Alcohol might help you fall asleep faster, but it severely fragments your sleep later in the night, preventing the deep restorative stages your brain and body need. So you wake up feeling exhausted, even if you slept for 8 hours. Third, there's inflammation. Your immune system responds to alcohol by releasing inflammatory molecules, which contribute to that general feeling of sickness, muscle aches, and fatigue. And finally, there's that toxic byproduct, acetaldehyde. Even after most of the alcohol is gone, small amounts can linger, contributing directly to nausea and headache. The familiar combination of brain fog, fatigue, thirst, and nausea is simply your body working overtime to recover from the biological stress of processing alcohol. Your body is remarkably efficient, but it has its limits. A healthy liver can typically metabolize about 1 standard drink per hour. When that limit is consistently exceeded over years, the consequences extend far beyond the liver. Long-term heavy alcohol use is linked to a host of serious health issues: high blood pressure, a weakened heart muscle known as cardiomyopathy, stroke, pancreatitis, nerve damage, and an increased risk for several types of cancer. So, what happens inside your body after drinking? In summary, it's absorbed with incredible speed, reaching your brain within minutes to slow down communication. Your liver drops everything to begin a detoxification process that creates its own toxic byproducts. Your kidneys are tricked into losing water, your heart rate changes, and your immune system becomes inflamed. The human body is incredibly resilient. It can recover well from occasional exposure, but repeated heavy drinking places a cumulative stress on nearly every organ system. Understanding this journey isn't about fear, it's about making informed choices, because every drink begins a biological story, and your cells remember that story long after the glass is empty. If you enjoyed this microscopic journey through the human body, subscribe to CellWise Health for more evidence-based explorations of health and longevity.